right? No one likes a silent classroom.
Is that why Zoom affected people so much?
Maybe. The Zoom lessons were hard because nobody turned on their cameras. And I get why you didn't, but it was like you didn't know if somebody was there, and all you saw, like from our perspective, was like a screen full of black rectangles. That was pretty terrible.
And then like one person with their camera on.
And there was no way of knowing like how you guys were feeling about stuff, and I don't like it that way. So we kind of talked about continuity on Monday after the quiz, right? So what was continuity again? Like, how do we check for continuity? Go ahead.
If the limit approaching from the negative side is equal to the limit approaching from the positive side, maybe.
That's part of it. Okay, so there's two things that need to happen, technically. I'd argue, actually, there's one thing that needs to happen. You need the limit as x approaches something. In this case, I'm going to use 2, right? Because that's where there's potential for discontinuity. Okay? You need the limit as x equals 2 of f of x to equal f of 2. Okay? So we need to essentially show this is true. That's our goal. Now, if I asked you guys to calculate f of 2, would I use the top function or the bottom function? Why would we use the bottom function? Because that's where x is equal to 2. Okay, so if I plug 2 into that bottom function, what do I get? 19. Cool. All right. So now what we have to do is find the limit as x approaches 2 of f of x. Okay? Now, because this is a piecewise function where it's like split at x equals 2, we have to essentially find the limit as x approaches 2 from the right and the limit as x approaches 2 from the left. Which function do I use for 2 from the right? The top one or the bottom one? The top. Why the top? Because that's where the x numbers are to the right of 2, okay? And when I plug 2 in there, I get 10? 10? And 2 from the left, I get 19. Okay, so is the function continuous at x equals 2? Okay. And if I asked you why?
Because the limit as x approaches 2 of the function does not equal f of 2.
I'm going to just say it does not exist, right? If that limit doesn't exist, it definitely can't be continuous. But also, yes. And if I were to ask you guys, is this a removable or non-removable discontinuity, what would you say? Non, because it's a jump continuity, or it's a jump discontinuity. Because at x equals 2, our value jumps from 19 down to 10. How are you guys feeling so far? Good? Is there a lot of black because of Goth Day? Okay. It's like a lot. Interesting. Okay. All right. New function. Is this continuous?
Not when k equals 1.
Not when k equals 1. Like, so, are you with me that if I just gave you this and didn't tell you anything about k, I just gave you the function, just this box right here. we wouldn't be able to say that their function is continuous or not continuous because this k is a constant of some kind, but we don't know what it is. Okay? All right. So let's start with sketching a graph of what this would look like right now. So we're going to start with k equaling 1. So if I put an invisible 1 here, okay? If I asked you to graph this piecewise function, what do we do? When was the last time you guys graphed a piecewise? Did you have to graph piecewise in AP? Do you remember? I know you did it in pre-calc. I just don't know if you did it in AP at all.
Briefly.
It's fair enough. You guys mean are you guys telling me you don't remember every single day of the past 2 years of math classes? That's ridiculous. Okay. How do I graph the line f of x equals x plus 1? If I asked you guys to graph that, what would you do?
Get 2 points and then draw a line between them.
Pick 2 points, okay. How would you get those 2 points?
You can plug in 0 and
Okay, so if I plug in 0 for x, I get 1 for y, so I have the point 0, 1. Or if we think about that from like y equals mx plus b way back, you plot the y-intercept, and then we can count that slope, right? So how are you feeling right now with this being the line y equals x plus 1? We good with that idea? Now, for the piecewise function, I'm not graphing the whole line. In fact, I'm only going to graph the part where x is less than 2. So I'm going to put an open circle on 2 and only shade the part that's to the left of that point. And then the rest of those points aren't a part of this function because, well, they might be, but we don't know yet. But that's all that piecewise function is you're graphing the line y equals x plus 1, but you're only graphing the ones where the x values are smaller than 2. And then likewise, to graph the other half of this, we're going to graph y equals x minus 5, the quantity squared. And we're only going to graph that to the right of 2. What does the graph y equals x minus 5, the quantity squared, look like? What do we know about that? It's going to be a parabola. Do we know anything else about that parabola?
pointing up, since it's positive, but
Say that one more time.
the x is positive, so it wouldn't be pointing down, like arcing down, it would be going up.
Yeah, so it would open up. Okay.
The x-intercept is 5,
The x-intercept is 5.
because that's when,
If I think of it, the x-intercept is going to be where y is equal to 0. So the x-intercept is going to be 5. Does it have more than one x-intercept?
no. No.
Are there any other values for x that would make this whole thing 0? So that 5, that 0.50, that's actually the vertex of my parabola. What if we just typed in y equals x minus 5 squared into our calculators? Could you guys do that? And then you could even use the table to help you get some other points. I think you would get something like at 4, you would get 1. And reflect that one over. I'll let you guys, well, heck, I can do it with you. We good? So we can use the calculator to get an idea of where the graph is. And if I hit second table, it'll even tell me, oh boy, who knows what I was doing with this. If I hit second table, it'll give me like a set of points. Okay. Which set of points do we care about?
What points greater than 2?
Yeah. since we're only graphing x minus 5 of the quantity squared where x is greater than or equal to 2, I'm just going to start my table at 2. Does that make sense? Those are the values I'm going to look at. So 2, 9 is like way up here. And then 3, 4. And so on. Oh boy, that looked terrible. So looking at the graph, is f continuous? How do we know? Yeah, the limit as x approaches 2 does not exist. Now, let's what I'd like to do, that was if k was equal to 1. What if I ask you, hey, we got to figure out what value do we want for k? Oh boy, I really screwed up that graphing. There's no arrow here. What's the limit as we approach 2 from the left? Three. And as we approach 2 from the right? So overall, that limit does not exist. What about f of 2? What's f of 2?
9.
That's this point. Oh, I should do it this way to color code this. That's 9. Okay. So here's the question. What needs, if I could pick any value, I'm being really slow. If I could pick any value for k, what should I pick? Can you talk me through that?
If we plug 2 in for x, and you set it equal to 3, because that's what the other one is.
Okay, so are you guys with me that the issue that we have here is that this 9 and this 9, these match each other, right? And those are, in fact, that k times x minus 5 the quantity squared, right? What do I want? If I get to change k, what do I want to find k to equal so that both sides are equal? You guys get what I'm saying there? So I can multiply this whole function, and when I multiply the whole function by something, it's either going to stretch that parabola out or it's going to shrink it down. Which one do I want to do to make this continuous? I want to shrink it, don't I? All right, so here's what I know. I know that k, I want to find the k so that x minus 5 squared is equal to x plus 1. But it doesn't have to be, it has to be equal at a very specific place. It has to be equal at x equals 2. Is everybody with me? That's the only way at x equals 2, at this one spot right here, I want both of these functions to be equal. So what I'm going to do is set both functions equal, and because I only need it to be equal at x equals 2, I'm plug 2 in for x. So I have k times 2 minus 5 squared has to equal 2 plus 1. And then all I have to, from there, we can simplify that out quite a bit. Like 2 minus 5, the quantity squared is 9. 2 plus 1 is 3. So k would have to equal 1/3. That's what I need in order for the function to be continuous. All right, guys, consider the square root of 9 minus x squared. Oof. First things, can x equal anything we want? Another way of saying that is, what is the domain? What is x even allowed to equal? Negative infinity to 3? So that would include like negative 5, right? That'd be taking the square root of 9 minus negative 5 squared. You with me? So would you like to revise your answer? Negative 3. I would agree with negative 3 to positive 3. Inclusive, because we could equal it, right? But if it was bigger than 3, I'm saying 9 minus some number that's bigger than 9. I'll end up with a negative number underneath my square root sign. And if it's smaller than negative 3, it would be the same problem. Okay. All right, so if I start to get to this graph, the first thing I'm going to notice is that this is negative 3 and this is positive 3. And I know that the graph only exists in between these two. Huh. What else do you think let's kind of think through this function and what it might look like. Does anybody have an idea? Like I might look at that x squared and think parabola. Kinda, right? Because parabolas have an x squared. But, Are you guys cool with me calling this y equals 9 minus x squared? The square root of x squared. And just for fun, we're going to rearrange this a little bit, okay? If I asked you guys to rearrange this, what's the very, very first thing you might consider doing? Squaring both sides? Okay. And if I do that, I get y squared equals 9 minus x squared. And then what I would probably do, because all of a sudden, when I see those squareds going on, this makes me want to write this as x squared plus y squared equals 9. What does that graph look like? Does that equation look like an equation you've dealt with before? What kind of shape is it? It's a circle. A circle with radius 3. But so like if I had a circle with radius 3, it would be all of this, right? But this is a function, and this is definitely not a function because it doesn't pass that vertical line test, right? But because this is the positive square root, we're only going to worry about the top half. Now, that being said, imagine it's your test. If I asked you to graph something like this on a test, I would hope to God you're not trying to go through this whole process. You should use a calculator to get there. Yeah. Okay. Is this function continuous?
Yes.
In its domain, yes.
Like in between -3 and 3, yes.
Okay, so this whole idea when we start to have this limited domain, because like we could make the argument that the limit as x approaches -3 does not exist, because it's not defined at both sides, right? So we haven't really talked about one-sided limits yet. So because this function is only has it has this, like, I don't want to call it a finite domain because it's not really finite because there's an infinite amount of numbers in between -3 and 3, okay? But because this function does not have, it is still a bounded domain, okay? Because it's bounded, the limit doesn't exist on both sides of those bounds. So what do we do here? So as we look at this, how do we decide, is a function on a bounded domain continuous? What you do is you're going to say, well, what's the limit as we approach that lower boundary from the right? And you guys see from this picture why we would approach the lower of those two boundaries from the right. Is this okay? Like, if I want to decide, is it continuous on this domain? Because that is the domain of the function. I don't want to approach this boundary from the left, because the function's not defined on the left. So you're going to approach the lower boundary from the right, because that's where the function approaches that lower boundary. What is, by the way, the limit of this function as as x approaches -3 from the right? So I'd be asking you, what is this limit? 0. And what is f of -3 if I plug -3 into the function?
0.
It is also 0. So it's continuous at that bounded area, where x is bounded on that side. Okay? What about the limit as x approaches +3 from the left? And do we see that the upper side of that boundary we approach from the left because that's where the function approaches an upper boundary? Okay? So as we approach it from the left, f is equal to 0, and f of +3 is in fact 0. So we can say this function is continuous just on this closed interval as long as we approach the lower, as long as these two match and these two match. So as long as the lower boundary and f of the lower boundary match, like that, as long as those limits match and so on and so forth. So it's really the same check for continuity. It's just that because the domain or the interval that you're checking for that continuity on is bounded, you only check some of it, okay? So here's what I'm thinking, just to break things up. If you need to take a break, that's fine. Before we throw too much at you at once, I was going to let you guys work some of the practice problems in that new homework packet. Does that make sense? Maybe just take 15-ish minutes. You can work those if you need to go to the bathroom or just, if you just need to do this and do whatever, the next 15 minutes are yours. So at 12:50, we'll start talking about the intermediate value theorem. And that gives you a decently long break if you need a decently long break, but also a chance to reinforce some of these ideas. And honestly, also for me to go get some water.
Oh, I see. I just that's why. Yeah. Like, bro, just look at it. Oh, what is it? Yep.
That's what you were saying. Yeah, I was really confused on the writing. Miss Meister. Miss Meister, is you don't have to pick up your pencil and medical evidence.
No. The analytical evidence would be that you found the limit, that you found the value of the function, and that the two are equal to each other.
It's just like a whole interval. It's not at a certain point. So like it's asking if like an interval is continuous. And so
Okay, so that's actually what we just talked about. In the sense, so if I want to show that, so
Oh, okay.
so let's say I asked you, let's go ahead and say I want to know is f of x equals, I'm making this up, x, is it like a nice function or is it an icky function? What kind of function did I give you?
It's kind of icky. It's like a parabola. It's not.
Oh, I gave you a piecewise?
Yeah.
Right, okay, I'm remembering this question now. Okay, so let's say I gave you this and I said this is 2 and this is 3 and we'll call this, that doesn't make sense. -2 and +1 makes a little bit better sense, right? Okay, and let's go ahead and call this value 2 and this value 1, okay? You with me?
Yeah.
That's a little bit more believable, yeah? Okay, all right. So, and I ask you, is it continuous on the interval -2, 1? Like that, something like that, right? All right, so what you would want to show is what is the limit as x approaches negative 2 from the right of f of x, and you would say 2. Then you're going to say what is f of negative 2, and you would say 2.
Yeah. Oh, it is. Yeah, yeah.
Okay, now what is the limit as x approaches positive 1 from the left of f of x? You're checking the boundaries here. 1. What is f of 1?
1. So I guess my question is how to, like, is it just assumed that all the values inside are continuous and not the proof?
Okay, so one of the things we said yesterday was that Monday, you weren't here.
I wasn't here.
Okay, we talked about like the different kinds of functions that are in fact continuous. A parabola is a polynomial function,
Okay.
and so the only places where functions are potentially not continuous are at the boundaries of piecewise, right? At where the domain is undefined,
Okay.
and then yeah.
Okay.
So because it's a polynomial function, the in between is fine. You have to check the endpoints.
So like there couldn't just like randomly be a hole.
There could be, but it would be graphed. Like you'd see it. I wouldn't give you something like that where it wasn't graphed. This is a great question.